Okay, so W1, right?
Yeah.
Is actually W1 of B. So wherever we see A, we put B. I hope so.
Yeah.
Okay. So wherever we see A, we put B, right? And then plus W1 of C, which is exactly the same thing, but C.
Okay.
Makes sense?
Okay.
No.
Because we're in another round.
No. This W1 is evaluated at B. Actually, what W1 of A is like 10, no, 2 plus 10A, right? And like we're just writing, we're using the same W1, but we want to be able to evaluate at two different points. So what we just, at B and C. So what we just do is that we just create like the B version of it and the C version of it, so that when B comes in here, it knows where it needs to go, and when C comes in here, it knows where it needs to go. Does that make sense?
So why do we never do it for A?
Because of, the function is usually like W of B plus W of C. A is the only thing that only comes in here. Like if you remember the see the function. Had I evaluated at A, B, C, but there's always this one of B and this one of C. There's never of A.
2 plus 10,
No, that one we just made A generic
Oh,
for the variable. So we just did 1 minus A and
okay.
it's generic, yeah. Okay, so that's the add side, right? Oh, you want to write it down? Yeah. We could make it W naught of A, but it's a constant poly that has no A inside. So regardless of your A is always going to give you 14. We don't yet know whether this is correct, so we'll know depending on what our approval says. Cool? Cool?
Yes.
So that's the add part, right? Now we're doing the more part. More was 0, so we don't need to do anything. It's just 0 times. So we're done with our F, A, B, C that can take you from W0 to W1. Okay? Now, we already know what our A is. Our A is 5. So let's get the full FBC. So wherever we see A, we're going to replace it with 5. And that's all, right? 5BC now? Oh, 5C. Good, right? No, I'm just leaving it this way. Or is there a simplified version?
So you can just add 2 plus 2, 4. And then you have 4 plus 9B plus 10C.
It is the most simplified version.
Yeah, this is the most simplified. Except you want to bring 2 out, which does not really matter.
Okay, so you feel like we can factorize our... C is common everywhere.
C minus 5C. That's minus 4.
Like, no, what I'm saying, like, it's factorizable.
Yeah.
5C minus
C1 minus B, then 5C1
okay,
minus
that's
B.
minus
So you have
4C
C minus 5C.
minus
Yes,
4C
minus
plus
4C minus
4BC.
Yeah.
Minus
Minus
4C
Minus
bracket 1 minus
4C
2. That's the
minus
right.
plus 4BC.
It's just what you can bring out is 2.
We're not bringing out first. You can do
You can
minus 4.
simplify
You can simplify it because you can bring out the same thing. No, you can simplify. When I simplified it, I got 4BC minus 4C. Then the other is I got 4 plus 10B plus 10C. That is the only two that is common in both. The only two that is common.
I'm not simplifying again.
No, it's not.
It's okay. It's okay.
Let me
No. It's fine. Is it much shorter when you simplify?
Yes.
What is it?
I have 4BC minus 4C times 4 plus 4B plus 4C. 10C, yes.
Is that much shorter?
Yeah.
Yeah, let me simplify. Why did you guys not? Oh yeah.
C minus 5 that is minus 4C. Minus BC plus 5BC, that is plus 4BC. Then 2 plus 2 is 4. We have 10B and 10C, that is what. If you now want to factorize 2 will come out.
From everything.
Yes,
So.
2 can come out from everything.
But it's fine like this. Good, right?
Yeah.
So now we have something that can relate W0 with W1. We're not supposed to do all this. I just realized we're not supposed to do all this.
Really?
Yes.
So we did it in the manual.
No, because of we still need to know what W1. No, the prover is going to give us W1 of B and W1 of C. So we need an equation that still has W1.
What?
Really?
It's supposed not to substitute that.
No, it's fine like this. It's just the second part that is wrong. So I'm going to call this F of BC, right?
Yes.
I'll still leave this part.
There's a mistake or something.
No, there's no mistake. Into what? W1 of. Let's leave it like this. But then just remember that this part here is W1 of B, right? And this part here is W1 of C.
I've seen anything like that. I'll just change down that 4BC minus 4C open bracket W1 of B
Yes.
plus W1 of C. That is it.
You're saying here we can do
4BC.
minus 4B minus 4C, right?
Okay, minus 4C.
Which is like 4BC
Minus 4C.
minus 4C times 2 plus 10 plus 2 plus 10.
Yes.
Where this one here is like W1 of B and W1 of C. Are we good?
Yes.
Because the program would tell us what it is and we need to substitute it back in
So you never needed to put that 2 plus 10
if you didn't want to, but it's so simple that this is fine. So now we can run some check, right? So 14 is supposed to be equal to the sum of that polynomial that we just reduced, which is this polynomial, over the Boolean hypercube, right? But then the verifier doesn't. So we're going to engage in some check now. What's the claim sum?
14.
Now, what is the FB polynomial? So we're supposed to evaluate C at 0 and evaluate C at 1 to get FB, right? So we're supposed to do F0 of B0 plus F0 of B1, right? Which will give us F F0 of B. That will be the round poly. Cool? What is F0 of B0? So wherever there's C, we replace it with 0, right? So this entire thing is changing to,
0.
which means that the entire thing is changing to. So this one here is. Does that make sense?
Wait, is it the verifier that is doing this?
No, the prover. the prover is trying to generate the round poly. So it's 4 times b, right? C is what? Minus 4 times 0, right? This is 0 minus 0, right? Which is 0. Then 0 times anything is still 0. So the answer is 0. Makes sense? Then we do for 1. So this will just be 4b minus 4, right? Right? Times 2 plus 10b plus 2 plus 10. Right?
That means we still needed to like put in the everyone in the real figure inside the previous function.
Why?
At this point, we've not
To
got
get
it.
And this is the prover doing this work now.
Okay, this is proper doing this. So
We're trying to get the. Yeah, he knows that we want. Are we good?
Yes.
We just replace C.
Plus 10b.
Don't worry.
So can we be writing what the people are preparing?
The prover is on the left side. The verifier is on the right side. So if I'm starting my this thing from this side, just know that it's the prover. Then if I'm starting from this side, know that it's the verifier. Let's simplify this now. So what does this give us?
4b minus 4, 14 plus 10b.
Right? This is our f of b polynomial. Huh? Huh?
14 plus 10.
Huh?
Is multi.
It's quadratic.
Yeah, multivariate.
Why is it quadratic?
You're supposed to have the values now. On the right hand side. Since this is proper doing this,
Must have made a mistake somewhere with that. Oh yes, it is supposed to be. It's supposed to be quadratic.
Some points.
The reason is because of this, right? You have your add that adds A, B, C, right? Then you're doing times,
Oh.
and this one has B in it, this one has B in it. So at some point, those two B's will multiply to be like square. And I think when you're doing your multiplication, okay, yeah, it's quadratic. Yeah. Yeah. We cannot even do it by hand then. You guys have no yet. There's this stuff that we need to talk about. Bruh.
So I'm saying that.
Is it not multivariate?
Yeah, it's univariate.
Huh? Yeah.
It's univariate, but it's not linear. So that means that your round pulley would now have like 3 things inside.
I don't understand.
That means
No,
like
I still don't understand
our
why
sum
it's
check this thing can
Yeah.
be
Just provide.
Okay, three. Okay. The evaluation form be three.
Yeah.
That means we've been using multilinear.
For your sum check.
even for the
Yes.
sum check and everything.
So everything is changed.
You're not going to be running sum check on. So it depends on how you want to do it. There's a way you do it where you get the multivariate polynomial itself. But there's a way to run sum check on a product of 2 multilinear polynomials. Hey, yeah. I'm just putting you guys. Oh my god. Bruh.
Wait. So you're saying now that if we are started implementing,
You don't even try it. Don't try it. Don't try it yet. This what we're talking about now is coming out in the implementation
that's what I'm
side.
saying. Like if you had said, oh, you have started implementing,
Then you
we
figure it
start
out yourself.
discovering this one.
Yeah,
Not
yeah.
that we don't know what.
No, now. That's
Yeah.
see. You're lucky that we are spoon feeding you right now.
Oh, you are?
Like we are spoon feeding you right now. The actual thing is like now, okay, we're learning Venus, right? I have a file of videos, like 10 videos, 20 videos. I'm watching every single one of them, one by one. I don't understand. Shit. I can't ask question. I am just watching. The goal of this stage is just to gather information. I'm not trying to understand anything. I'm just watching back to back. Don't understand anything.
So
That's the first step. You just expose yourself. Know what is important, what is not important, all those kind of things.
So your
Then-
mental model is not yet strong enough.
It's not strong enough there. There is no mental model there, sir.
Are you okay now? If you like to open the video, your mental model just break.
So now, after that, I'll now have like a ranking of things that I want to now like fully understand, right? Then I'll have to go and start searching for that explain those things. Hopefully, it's not only in the paper that I can find it. Because it's only in the paper, then I have to now go to the paper. So I don't know how long it's going to take to finally create that neat mental model. But I know it will be created at some point.
And you still like implementation.
Huh? Then we'll not come and teach you guys.
But you still like implementation.
Yeah, we'll see our implementation.
What do you call it?
We'll implement it.
What
Binions.
do you call it?
Binions. Binions.
Brian.
Is that a?
B is a proof system.
Eh?
It's a proof system.
Is it what?
Proof system. So I know what we'll do. You guys have a high level of GKR now, right? Right? Then you're good. You can leave the class. So what we're going to do tomorrow. Eh? What we're going to do today. After break. Is we'll now start looking at sum check again. But now sum check not just on a multilinear polynomial, but on a product of multiple multilinear polynomials.
So all this thing, once you get to that sum check part, my head will just because
It's not summing.
like I'm processing how this thing will go through sum check.
So now you guys should just you can still continue watching stuff on GKR, but you can pause you can now black box GKR. Now we're going back to sum check to see the modifications that you need to make to your sum check protocol, right? And then go over each of them. Then you guys now go back and let's go for break.
But we can finish this.
We can finish
With hand.
No.
I have a question.
Why can't we finish it?
This part now.
Yeah,
You said
we can't technically.
You said the program knows the WI or WI of why don't you just put the values into that part? Plus 10B and plus 10.
Which values?
Plus 10B WI of plus 10 WI of but the program knows it.
That's them now.
Put the value without just
So you don't have to.
You mean like
from the second.
the evaluation form?
Exactly, the actual value.
And it still won't matter now.
You will now be able to do that because it's going to be an actual number.
It seems like you're still leaving B as a variable, right?
What's not the point of saying that when I'm coming back?
Yeah,
Let's make it to the end of the class.
145. No, 145.
That's not 30.
It doesn't have to be up to 30 minutes. 145.
Plus or minus. There's something else.
Technically, that's what we're already doing, right? Like this 2 plus 10 is 12.
Plus 10 minutes.
It still reduces down to this.
No, I think it's 20 plus 10 actually.
C is 1.
Let's say we reduce this down to. It's like we had the polynomial form, coefficient form, and evaluation form. You can always get back the. Like this is the W1 of B, and this is W1 of C. The only thing we're replacing is C at 1, which we can always get from C at 1. That's 12, right? That's what is here. But then it's not like still 12 plus 2. That's what we got 14.
No, just mean that without doing it at 0 and 1, I just
You could do that. But we know we got equations so that we can leave evaluation form. But you could technically do that. So now we're supposed to run some check on something that looks like this. This is a product of two multilinear polynomials. So that's what we want to look into next. Bruh.